Hello there, boys and girls. Welcome back to another lesson in calculus. This is Mr. Bean, and today we're going to have a lesson on the average value of a function. Now, I'm pretty pumped about this lesson today because I've seen kids make mistakes with this stuff hundreds and hundreds of times, and I think I've got figured out how to help calculus students understand how to do this correctly. So let's get into this lesson and start us off. We're going to begin remembering what the average rate of change is. Okay, so what's the average rate of change? That's just the slope between 2 points. That's the average rate of change if we're thinking about just 2 coordinate points, or it's the slope of the secant line if we go back to unit, what was that? I guess unit 1, unit 2, somewhere back then. So again, we're talking about the average rate of change, not the instantaneous rate of change. And then we have this thing called the mean value theorem that we've talked about so much before. This is when we have the instantaneous rate of change is equaling the average rate of change. So we say that there's some x value, some input value c, that's in between a and b when the instantaneous equals the average. Okay, this is all review. We've done this lots of times this year, but I wanted to remind you this because what I'm going to do in the practice is I'll throw some of this stuff out at you. I'll throw out the average rate of change, and I'll throw out the mean value theorem dealing with that average rate of change for derivatives, so that you get used to when to identify that compared to when to identify the average value of a function, which is different, because now we're dealing with the integrals. Okay, so let's get this written down and I'll explain what this represents. But you can see here it's 1 over b minus a. This really, sometimes you'll see some textbooks, I'm going to write this on the side here while you're writing. Some textbooks will say from a to b of f of x, and then instead of putting the fraction in front there, they're just going to say that whole thing is being divided by b minus a. All right, but that is exactly the same thing as this. It's just saying 1 over b minus a. Okay, so have that written down. Pause if you don't have that yet. So let's put this into practice. Find the average value of this function on the interval -1 to 3. So what is that talking about? Well, here's -1, and my function is right here at a y value of 5. And then we're going to go to 3. Well, where is it at 3? It's down here at a y value of -3. So I'm going from 5, and then I go up here to 6. So the highest is a 6. And then you can see here it's a 5, and then down here it's a 2, and we continue, it hits a 0 right there, and then down here to -3. So what would be the average y value? If we start at 5, go up to 6, down to 5, and so forth. Well, the cool thing is to figure out that average y value, we use this fancy formula for the average value of a function. So let's do it. We're going to set this up, so write kind of small. I know I did not give you a lot of room, but that's because I wanted to fit all of your notes onto one page here. So we're going to do 1 over, whoops, not b minus a. Let's write out what b minus a is. So we'll go 3 minus -1, and then the integral from -1 to 3 of 6 minus x squared, and then of course with respect to x. Okay, so what does this equal? This is going to be 1/4, and then we have antiderivative of this is 6x minus x cubed divided by 3, and then we're going to evaluate that from -1 to 3. So we'll plug in the 3 first, and then subtract the -1 plugged in. So I'm going to draw an arrow up here to say that I'm continuing on. So I'll leave this 1/4 in front, and then plug in the 3 first. So 6 times 3 is 18, minus 3 cubed is 27, divided by 3 is 9. Okay, I'm taking some shortcuts, doing some mental math here. And then minus, so let's say I'm going to put brackets around this because it's got to be 1/4 times this whole thing. Minus, now let's plug in the -1. So I have -6, and then plus 1/3. All right, so I'm doing some mental math here as I plug in the -1 and then close my brackets. If I simplify all of this, I go through the math, you're going to have to trust me on this. Once I distribute, simplify, distribute the 1 first, simplify the fraction, I'm going to get 11/3. Okay, I already worked this out in advance, so just trust me on that one. That is the same thing as saying it's 3 2/3. So the average y value here is 3 2/3. Where in the world is that? Let's draw a line across this thing. 3 2/3 is about right there. So you can see it happens in two places. It happens here and it happens here. Those are the two places it happens. So that's the average y value, but I ignore this one because that's not within the interval from -1 to 3. So this is the spot where it occurs. So when does this function assume this value? Well, the easy way to do that is, again, I know you don't have a ton of room. Let's just take 11/3 and say that it's going to equal the function 6 minus x squared, and we're going to solve that thing. All right, so common denominators, let's see, this would give me 11/3 minus 6, which is 18/3, equals a negative x squared. Again, let's draw this arrow up because I know you don't have a lot of room on yours. So -7/3 equals negative x squared. So I divide by negative, take the square root, and x is going to equal plus or minus the square root of 7/3. Well, what is that? I plug it in a calculator and I get approximately, I can ignore the -1 because you'll see here it is approximately 1.578. If I needed the exact value, it'd be the square root of 7/3. If I want a decimal, it's 1.578. So where's that 1.578? It's right about there. That's perfect. That is where the dot is. All right. So what did I just do here? I figured out when does the function equal its average. That is the mean value theorem for integrals. So it's figuring out this value of c when, actually let me fix this. This should be little f, not capital F. I gotta fix that. So little f of c. So when little f of c equals the average value of the function on that interval a to b. So again, I didn't put a lot of the other extra stuff in here, but I am assuming you know that c is, and you might write this on the side here, is going to be in between a and b. C has to be in between a and b on this interval. There's going to be some value in which, if we plug it in, we will get the average value of the function. Okay, so we have mean value theorems for derivatives, which we've been doing for a while, and now today for integrals. So I've got just a couple examples. These notes are fast, man. You're going to love this. Then we have lots of practice for it. So we're going to compare the average rate of change, which is talking about the secant slope, versus the average value of a function. And we want to make sure we have those straight because they come up so often on an AP exam. What is the average height during the first 3 seconds of this thing? So we have h of t equals blah, 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 blah. And h is the height in feet, t is the time in seconds. We're going to set up the equation, but we're not going to solve it. But I also want you to focus on what will the units of the answer be. What units will the answer be in? Okay, so here's how we do this, the average height. So I want the average of h. The average of h. That just means the average value of this thing. So that is 1 over the first 3 seconds. B minus A is 3 minus 0. So I'm just going to put a 3. And then I evaluate it from 0 to 3. And then I can just say h of t. All right, I don't need to write this whole thing out because all I'm doing is setting up the equation. And on the AP exam, if you are allowed to use a calculator, this is what you could do. You could just say it's h of t. You don't need to spend the time writing out -16 t squared plus 41 t plus 10. Why do that? Save yourself some time when you get to use a calculator and just set this up like this. Okay, so I could plug this in a calculator and get directly to the answer, but we don't need to solve it. This is just practicing setting it up. And then what are the units going to be? Well, the average height, the height is in feet, so we're talking about the answer will be in feet. All right, next one. What is the average velocity? Well, the average velocity would be the average rate of change of the height. So that means we're going to do h in the first 3 seconds, h of 3 minus h of 0, divide that by 3 minus 0. Or I could have just put in 3 here. Okay, so this is the average velocity. Not the instantaneous velocity, that would be h prime, but the average velocity, which is just the slope between 2 points. Okay, and then what are my units? This is going to be in feet per second. Feet per seconds, or in other words, we could say feet/second. It means the same thing. All right, next one. And it's the last one already. Holy cow. All right, so here we've got r of x equals blah, 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 where r is the rate. Now this gets tricky. R is already a rate. Okay, and what is the rate at which Mr. Bruss' waistline is changing in inches per month? And x is time in months. Okay, so what is the average rate that Mr. Bruss' waistline changes from the 10th to the 12th month? So here's the problem. You see these phrases, average rate? This is where kids mess up. So let me go back to this real quick, and then I'll come back to this problem. What was the very first thing we were recalling? Average rate of change. It was the slope between 2 points, remember? Average rate of change, slope between 2 points. So immediately, when kids see what is the average rate, they think, oh yeah, I know this. It's the slope between 2 points, from the 10th to the 12th month. But the problem here is that r of x is the rate. This is the rate at which Mr. Bruss' waist is changing. So when we want the average rate, we want the average of this thing. So what we're really doing is saying 1 over from the 10th month to the 12th month. So it's 12 minus 10, so it's just a 2. Oh, I switched from red to blue. There, prettier. Okay, so 1 to 2 from the 10th month to the 12th month of r of x dx. This gives me the average rate that Mr. Bruss' waistline is changing between the 10th and 12th month if I evaluate this thing. Okay, now what are my units? My units would be inches per month. So what is the average change of this rate during the first 5 months? So now we're talking about how much is this rate changing by. This is when we're figuring out, okay, I want to know average change of this thing. That is not the derivative, that's instantaneous, but the rate between the 10th, oh no, the first 5 months. So we're going to go r of 5 minus r of 0 over 5 minus 0, so just a 5. Okay, that would give me the average change, or the average rate at which the rate is changing. I know it's a little confusing, but you got to be real careful about thinking what was the original function that they gave us. So what about the units of this thing? The units would be inches per month per month. So it's how fast the inches per month are changing per month. Or in other words, the shorthand of that would be inches, and I still see some of my students doing this wrong even this last week, inches per month squared. When it's per month, you just say month squared like that, or second squared if it was seconds. Okay, man, that was pretty quick on the lesson. I know that wasn't a lot of examples, but really the only way you're going to get this, it's pretty straightforward, but you just have to practice through some scenarios. So I've put a lot of AP free response type questions that are in here to get you some practice, pulled out some from the early 2000s to help you out. But really this is it. So rock that mastery check, and I will see you back in the next lesson.